Alright, here are solutions for quiz 6 for Math 243. First problem here, let's see, we're dealing with proportions. 70% of students think there is too much information crammed into Math 243. Pretty fair thought. This is P, our population proportion. It's 0.70. In a random sample of 400 students, number of students I have, that's N. What is the probability that less than 300 of them think there is too much information crammed into this class? So what this tells me is that P hat is 300 out of these 400. In other words, 0.75. Describe or justify the shape, center, and spread of the sampling distribution of the proportion. Alright, shape. Approximately normal, because it always is. But more specifically, because N times P times 1 minus P is greater than or equal to 10. How do I know it is? Well, I don't. I guess I should calculate it. Let's see here. My calculator up here. Let's see. N is 400. P is 0.70. And I'll multiply that by 1 minus P, which is 0.30. And I get 84. I don't know. I guess you could write this. 400 times 0.7 times 1 minus 0.7 is equal to 84, which is greater than or equal to 10. Shape, center. The center is given by P here, so the notation we use is mu sub P hat. It's kind of saying the population average of the sample proportions is 0.70. It's always equal to P. The spread, in other words, the population standard deviation of these sample proportions, comes from the formula P times 1 minus P divided by N square root. So I can figure that out in my calculator. 0.7 times 0.3 divided by 400 is not what I want. I want the square root of that answer. And I get 0.0229, 0.023 maybe. Good enough. Shape, center, spread, something like that. This is hard to read. 0.229. Answer the above question by sketching and labeling the relevant picture. Alright. So now that we have all that information, I can draw something that's approximately normal. Because I said the shape's approximately normal. I can put the center as 0.70. Because I said the center should be 0.70. And then I want the probability that less than 0.75 of them. So 0.75 is somewhere over here. What I want to do is shade this side. Good enough. I'll shade a little bit more. This shaded area right here. So I want to figure out that probability. The way I can figure it out is by using normal CDF. When you're using the normal CDF function, which is under the distribution menu, so I'll hit second and then variables. I tell it the left bound, so I want a large negative number. The largest that my calculator will understand will be negative E99. And my right bound is 0.75. My center is 0.70. And my spread is this mess. The square root of 0.7 times 1 minus 0.7 divided by 400. And if I throw all that in, negative, for scientific notation, that E99, you want these E's. So second comma, 99, comma 0.75, comma 0.70, comma the square root of 0.7 times 0.3 divided by 400. That all look right. Looks good to me. Hit enter, and I get 0.9855. Or, if you'd prefer, 98.55%. Alright, moving on. During an African safari, I caught and weighed 550, 50, not 500, 50 black rhinos, there's N. I summarized my findings by calculating the sample average weight to be 1,500 pounds. That's X bar. I should switch colors here. These are going to all run into each other. So I have 50 rhinos, that's N, and 1,500 is my sample average. We use X bar for that. Sample standard deviation of 500. I'll use S for that. I noticed that the weights in my sample were right skewed. Turns out that doesn't matter. Describe the shape, center, and the spread. All right. Shape, center, spread. Shape is approximately normal. And the reason it's approximately normal is because N, which is equal to 50, is greater than or equal to 30. And then in parentheses, I'm going to say it's a t distribution because sigma is unknown. Center. We'd like to use mu, but we don't know mu. That's what we're trying to create a confidence interval for here. So instead we'll use X bar. And X bar in this case was 1,500. Maybe I should make these colons or something. And the spread, well, we don't know sigma, so we'll use S as its approximation, sample standard deviation. However, because I'm talking about the spread of a sampling distribution, I want S over the square root of N. So I want 500 divided by the square root of 50. That's my spread. Create a 90% confidence interval by sketching and labeling the appropriate picture. Now that I know shape, center, and spread, I can draw something that's approximately normal. I can put the center here as 1,500. Then I can go into my calculator. If you hit stat and then tests, you'll see t interval. Why t interval and not z interval? Because I said it's a t distribution up here. So we want a t interval. I don't have the data itself. I don't have a listing of the 50 weights. I have statistics about the data. X bar, that's 1,500. S, that is 500. A little bit tricky here. You don't put in 500 over the square root of 50. You put in 500 on this line, and you put on 50, or you put in 50 on this line, and it calculates that spread for you that it uses. But you don't actually type that in. We want a 90% confidence interval, so you can put in 0.9, 0.90, 90, any of those will work. I'm going to calculate. And it thinks for a minute. And what it tells me is that if you go down to 1381.4 or up to 1618.6 and use those as your endpoints, then what you've done is created a 90% confidence interval. 90% is the area in between these 2 points. Because it doesn't tell you to interpret this, so I don't have to interpret it. That is the end of this quiz.